Hi everybody, we're going to have a quick look at slope-intercept form. Slope-intercept form is a way of representing a line on a Cartesian plane through an equation. So over here on the right hand side we have an equation, y equals mx plus c, and we're going to use that to represent all the points on this line. This equation has a few components. It has x and y, which represents a point on the line. We have m, which represents the slope of the line, and we have c, which represents where it crosses the y-axis. So let's make sure we label our axes. So in the case over here, we have y equals 2x plus 1. 2 represents the slope of the line, whether it's steep, whether it goes from left to whether it goes up or whether it goes down, whether it's shallow, whether it's steep, is all represented by this number over here. The x and y represents all the points on the line, and the one at the end represents where it crosses the y-axis. Now, for this line here, it would have a c value at the end here of 0, because it crosses the y-axis at y equals 0. So let's just look at this equation for a second. The coefficient of x is 2, so the gradient of that line is 2. And the y-intercept would be at 0, 1, because the c value is 1. It would cross the y-axis at 1. So, what does this gradient number actually tell us about the line that this equation represents? Well, if m was 1 and the two axes had a similar scale, it would represent a line at 45 degrees. And because it's positive, it's going to be, well, we can think about it as uphill. From left to right, it's going up. If m was negative 1, if this value in the equation was negative x, or just the negative part, it would be going in the opposite direction. It would be going this way. Or if we were going from left to right, we think about it as going downhill. Now, if m was a half instead of 1, the slope of the line is going to be shallower. So it's not going to be quite as steep as this one was for a similar positive value. And that's obviously the opposite when this number increases. So if the number in front of x is bigger, instead of being a half, it was 2, the line would be steeper. Now, we'll look at how to determine that value from a line later on, but for now it's enough to know that a steeper line is going to have a bigger coefficient, a shallower line is going to have a smaller coefficient, a line going up will have a positive value here, and a line going down will have a negative value here. Alright, now the nice thing about a linear equation in slope-intercept form, if we know 3 of the 4 components, this being the 4 components, x, y, m, and c, if we know 3 of them, we can always find the 4th. So, we might want to know what's the y coordinate of a point on this line here, and I should really give it some arrows. If we have this line here, and we know that we want the y value if x is 3, and the equation of this line was y equals 2x plus 1, what would this y value be? So, we can work it out. What we do is, we put 3 into the equation and substitute it in for x. So here it is. Y equals 2x plus 1, substitute x equals 3, put 3 where the x is. The corresponding y value, this value over here, would be 7. And we can do that for any time that we know 3 of the 4 components. If we know x, m, and y, we can find c. If we know y, x, and c, we can find m. If we know, what else is there? We've done x over here. Whatever the 4th one is, we can do that too. And that's all for this little look at slope-intercept form. I hope that's helpful, guys. Thank you.